Hi, I'm Mrs. Milliken, and I'm trying to help you figure out how to do acceleration problems when you're trying to find the velocity or the time. And if you look at our starting screen here, we have the chart that we've been using in class to show our work. It's kind of a nice little system to be able to show like what you know, the formula you're using, a place to show your work, and then an answer with the labels. So if you like put this on a piece of paper or use your worksheet to like fill this out, this will help you organize your problem. And then we have also some different ways that you can show the acceleration formula. Um, Sometimes you'll see it this way: acceleration equals change in velocity divided by time taken. You'll also see this in a lot of places: acceleration equals final velocity minus initial velocity divided by time taken. And then here's a abbreviated form of the formula. A is acceleration, VF is final velocity, VI is initial velocity, and T is time. Remember, final velocity is the velocity at the end of the situation for the object, and initial velocity is the velocity at the very beginning of the situation. Down here have a formula or problem for us to solve, kind of to practice using this formula. So if you look along with me at this problem, it says the acceleration of a runner is 5 meters per second per second. Meters per second is the same as meters per second squared. It's just a unit of measurement for acceleration. It says the runner starts their race from rest with an initial velocity of 0 meters per second and reaches a final velocity of 10 meters per second. How much time does the runner take for this to happen? It would be good for you to like list out what you know first before you do the problem. So the acceleration here was 5 meters per second per second. The final velocity here was 10. The initial velocity, they said they started from rest. Rest means 0. They aren't moving. And for the time, we don't know the time, so we're going to put a question mark. If you notice, I put the formula for acceleration in the chart. Final velocity minus initial velocity divided by time. And if you went through and you were trying to put all these numbers in, I'll just go ahead and do that. I'm going to just put the numbers part of it in, meters per second. So 5 is our acceleration. We had 10 meters per second minus 0 meters per second. Oops. And then we divided everything. Okay. Oops, sorry. Making little typing errors. And then we divided everything by our time, but we don't know our time, so we'll just put T. Okay, now down here, I did kind of work out a little bit with the problem. I put the formula here. I took the same information that we put up in our substitution box and wrote it out. We have to use like rules like what we have done in the, like math classes to kind of get our time by itself so we can solve for t or time. So down here, what I did is I took 5 meters per second and I just took the 10 minus the 0 and said that's equal to 10 over t. Okay, and if we want to get the t by itself, we need to like use some ideas from math. So we have 5, or we're going to take the t from down here, we're going to multiply each side by t. So we're going to take the t times this side, and we're going to take the t times this side. Okay, and that would give us 5t equals 10. The t's over on this side will cancel out. Okay, and then you would be left with 5t equals 10. Remember, we always do the opposite operation when we want to get a variable by itself. So this is multiplying, right? 5t equals 10. So we're going to divide to get by itself. So 5t divided by 5 on both sides. The 5's would cancel out, and 10 divided by 5 would be 2. So our time is 2 seconds. So we could go back up to the top here in our chart and say t equals 2 seconds. Okay. All right. So that is our first problem. Second problem, I have an acceleration problem where we're going to try to look for the velocity, right? So it says a car accelerates 50 meters per second squared from rest. Again, rest always means sitting still. So that means 0 for velocity. So it says initial velocity of 0 meters per second. This takes 5 seconds. What was the final velocity of the car? Okay, so again, it's really useful to kind of put what everything is at first. The acceleration in this problem is 50 meters per second squared, or we could write it meters per second per second. The final velocity, we don't know, so we'll put a question mark. The initial velocity, they said it was at rest, so it's not moving, 0 meters per second. And this took 5 seconds. All right, put our formula in here. A equals final velocity minus initial velocity divided by time. I went ahead and put the measurements in here. So we have 50 is our acceleration. We don't know our final velocity. Our initial velocity is 0, and this happened like 5 seconds. Okay, and so I went ahead and I put some information down here to kind of lead us through our problem. Here's our formula. I wrote all the things out that we had up here. Okay, and notice we have this 5 seconds down here at the bottom, and we're going to need to try to get the final velocity by itself. So we're going to try to move everything over to this other side. VF minus 0 would be VF, right? But we have this 5 down below, and normally in math class we should, if we show division and we want to get something by itself, we multiply both sides. So we're going to take the 5 seconds times 5 seconds on both sides to get rid of that. So down here, that's what I did. I took 5 times each side. So the 5's over here are going to cancel out, and you're going to be left with VF for final velocity. Over here, we also took it times 5. So 50 meters per second squared times 5, which would be 250. And that's our VF. We got VF by itself. So 250 meters per second would be our final velocity. And we can go up here and put that in. VF equals 250 meters per second. Okay, so really what you do with these problems is you fill out your formula, look at what you need to get by itself, use a few little math things to get your variable by itself, and you should be able to figure out what velocity and time are from that. Thanks.